The rational roots theorem, now that's cool. So we'll try. Dividing polynomials. 3x plus 6 divided by x plus 2. I take x plus 2, divide it into 3x plus 6. People used to see us do long division. They did like something called like the candy cane method or all sorts of other things. I don't know how you learn long division, but this is how you do long division. Okay, you learn candy cane method, Ty?
No.
Okay, you just like candy canes. I'll bring you one tomorrow, okay? All right, I got you, all right? Just at the end of the lesson, say that was cool, and I'll bring you a candy cane. What do you multiply x by to get 3x? So you put the 3, since it's a constant, you put above the 6. And then you multiply the 3 back through, you get 3x plus 6. And when I subtract these, I get 0. Now, that shouldn't be too surprising, because if you took 3x plus 6 and you divide it by x plus 2, notice you could factor 3 out of the top, and then the x plus 2's would just, reduce to 1, right? I mean, that's not surprising at all. But that's easy to see, because you can see that 3x plus 6 factors easily. Can you see how that factors? No, you don't know. You don't know how that factors. So we're going to figure out through a division process. I write down x minus 2 goes into, I got x cubed. Anybody know what comes next?
0x squared.
Very good. 0x squared minus 6x plus 4. Remember 0 for the placeholder. That really matters when we're doing processes like division. Is everybody clear about the 0x squared? Okay. What do you multiply x by to get x cubed? X squared. It goes above the x squareds. I multiply the x squared back through, and I get x cubed minus 2x squared. And I subtract those pieces. X cubed minus x cubed. 0. 0x squared minus negative 2x squared. Positive 2x squared. Now, I drop down the negative 6x because I have a binomial out front. I want a binomial there. They need to match in size. And then we start the process again. What do you multiply x by to get 2x squared?
2x?
Yeah, 2x. I'm going to take that 2x and multiply it back through. I get a 2x squared minus 4x. Uh-oh. 2x squared minus 2x squared, I know that's 0. But what is negative 6x minus negative 4x? Negative 2x. Then I drop down my plus 4. What do you multiply x by to get negative 2x? You multiply by negative 2. That goes over the 4. Negative 2x plus 4. I subtract and I get 0. Woo! Now, Adrian, any chance on the test that you go through that long division process and you possibly make a mistake?
Yeah.
And you're like, I wish I knew if I had that right, because there's a lot of pluses and minuses on the board, right? Everybody, like, it would be nice to check your answer real quick, right?
Yeah.
And here's a great thing. It's in conjunction with the rational roots theorem. It's called the remainder theorem. Notice our remainder here is 0. There's a way to check to see ahead of time what the remainder should be. All you do is you take the solution to that guy. What is the number you plug in to get 0 there? Dos, which is Spanish for 2. And you just run that right into here. So I got 2 cubed is 8 minus 12 plus 4. What is 8 minus 12 plus 4? 0. That tells me my remainder. So that's a really good indication I probably did the problem correctly. You see that? The remainder theorem says if you take one polynomial and divide it by another, okay, the remainder will be whatever that solution is plugged in. Okay? And to YouTube Nation and all the math teachers watching right now, I know I said that in a horribly grammatically incorrect way, but we're just trying to get through here. Flip it over to letter D. First of all, I want you to use the remainder theorem to figure out what should the remainder be in this situation. What should the remainder be? Figure out what the remainder should be, okay? And what'd you get?
-1.
-1. Okay. All right. -1. Now, if we were to set this up to see if it works, we would have a positive 1 out front. Well, I'm sorry about that. We have an x minus 1 divides into x to the 4th. We'd have a 0x cubed, a minus 4x squared, a plus 0x, and a plus 2. Now, everybody agreed that that's going to take us a while to do the long division. Let's just stop. Okay? Let's just not do it. In fact, how about I don't give you an assignment at all on long division? I just put a couple problems on the study guide, and you kind of got the idea right. Okay? Practice it. If you want to try this problem on your own long division, that's fine. Well, let's do another way. Let's do synthetic division. Synthetic division is faster. Synthetic division goes like this. You take the number that produces 0 out of the divisor, which is 1. Whoops, sorry about that. And I get that, your previous math teacher maybe organized this differently. There's not just one way to do it. I got my way, and I'm going to do my way because it's America. It's a free country. I do whatever the heck I want. Okay, so what numbers do I put across the top? The 1, 0, a 4, 0, and 2. And then I put another little box at the end, and I put an R there because that's where the remainder goes. The remainder goes under your last one. And we already said the remainder should be what? Should be -1, right? That's what it should be. We already determined that. And so synthetic division does the same thing that does. But what we do is we take this first number, we just drop it down for 1. Okay? Just drop that first number down. And then we multiply. 1 times 1 is 1. And instead of subtracting, we add. It's much nicer to add than it is to subtract, right? 0 plus 1 is 1. Multiply, 1. Add, -3. Multiply, -3. Add, -3. Multiply, -3. Add, -1. Did we match our remainder? Absolutely. So what do these mean? These are our coefficients for our next terms. That's the remainder. This is the constant. That's for x. That's for x squared. That's for x cubed. Okay, I just worked my way backwards. So I have x cubed plus x squared minus 3x minus 3. Very good with that? I got that darn remainder, right? Well, watch this. I'll show you what to do with the remainder, okay? If you take 5 and divide it by 3, how many times does 3 go into 5? Once. What's the remainder? 2. So 1 is your quotient, 2 is your remainder, but we say it's 1 2/3, right? 3 is your divisor, okay? So notice it's 1 2/3. So your quotient is this guy. Then you need a remainder, which is -1, over the divisor, which is x minus 1. That's how you write the result. Remainder of -1 over the divisor of x minus 1. I know it may look weird and different. You've been doing it your whole life, okay? 5/3 is the same as 1 2/3. Same thing. Everybody okay? Okay, I'm going to do one with you. You're going to do one on your own. You help me. What number do I put out front here for synthetic division? Put a 1. Numbers that go across the top are 1, -4, 2, and 1. What's the first step? Drop the 1. I multiply and get 1. Do I add or subtract? Add and I get -3. Multiply. -3. Add. negative 1. Multiply, negative 1, add, I get 0. So therefore my answer is x squared minus 3x minus 1. That's my result. You try letter B on your own. Try letter B on your own. Any questions? What do you think of that, Connor?
Good.
What do you prefer, synthetic division or law division? Had a class one time, it was an Algebra 2 class. I got them so proficient at law division, when I went to teach them synthetic division, they didn't want to do it. It's like, we like law division better. Like, you're the first people I've ever said on the planet. They're like, law division is so much easier. I get it. Like, why even drawing the half box thing? I'm like, oh my gosh, okay, all right, well, teach your own, right? I'm not going to judge. Just took them 5 times longer. So why do we learn law division? We do it for the rational roots theorem. Why do we do the rational roots theorem? We do it for this right here, okay? Flip your page over. We're going to get back to this other one in a second here. I'm trying a different approach. Doing my best. Try something different every day, okay? Yeah, this thing. How does it factor? You got a factoring method for that? Anybody here got a great idea for how that factors? You want to factor out an x? You want to factor out a 2? You want the, well, 3 doesn't have an x, right? So that doesn't work. You want to try grouping? You try grouping, it ain't going to work. Let's try. You group these two together, those two together. I could take out an x squared. I'm left with 2x plus 9. And then I can't take anything out of the next one. So did grouping work? Absolutely not. So you say it's prime, right? Right? Wrong. It factors. Can everybody just admit right now, you got no idea how to factor that? Like, you could, I bet, like right now, we could have a challenge. I'm going to give you guys an hour. I bet somebody would get it in an hour. I bet you try enough things, you'd probably get it in an hour. But I'm guessing it's going to take you at least a half an hour. Anybody else? So let's see how we factor that then. It's no big deal. We use the rational roots theorem. Okay? Break on over to the other side here. Rational roots theorem. What the heck is the rational roots theorem? Rational roots theorem says, let us have a polynomial and let it be of this form. A sub n times x to the nth plus a sub n minus 1 times x to the n minus 1. You're like, what the heck is that? All that's happening is what's happening to the power each time. The power is reducing by 1 every time, right? So it's just saying, suppose we had a polynomial of like 12x to the 5th minus 6x to the 4th plus 9x squared plus 7x minus 2. Okay? There's our polynomial. Just descending, and it's got coefficients. And this last term here is a constant. Okay? Negative 2. Okay? It says to focus on a sub n, which is the lead coefficient, like that guy right there. Okay? And it's going to say that let a sub n have factors of q. We're going to call them q. Q are factors of the first one. And then it says to focus on this last guy there, that last guy right there, and it's going to have factors what we call p. Whatever solutions this thing has, any solutions that exist that are rational, any roots is another word for x-intercepts. It's another word for zeros. It's another word for solutions. Those all mean the same thing, okay? If there are any solutions, they're going to be of the form plus or minus p over q. You just take factors of the back and factors of the front, and that's going to tell you what your possible solutions are. Now, there's a key piece here, this word rational. Can somebody give me an example of a rational number? I heard one. How about 3/5? How about negative 17/9? Can you give me an example of something that's not rational? Pi, root of 2. So we're not talking about those. Rational root theorem cannot find those, but it can find all those. You're like, what? You're still kind of confused. You're like, what the heck does it mean? It means this. Suppose I had 12x squared plus 19x minus 18. Now, I picked this one because it's not so obvious how that factors. We have to take a while to look at that, wouldn't we? But it turns out that this factors, I just worked it out a little while ago, factored out to 3x minus 2 times 4x plus 9. So here's what you need to lean in on. What is then the solution? What's the root to this right here? What number makes 0 here? 2/3. And what number makes 0 here? Negative 4 over 9, right? Okay. Well, what are the factors of 18? 1 and 18, 2 and 9, 3 and 6. What are factors of 12? 1 and 12, 2 and 6, 3 and 4, right? Look at this. Where did the 2 and the negative 4 come from? Those are factors that sit... I'm sorry, this should be negative 4, 9 should be negative 9/4, right? Sorry about that, you guys. Where did the negative 9 and the positive 2 come from? They come from right over there. Where do the 4 and the 3 come from? They come from right over there. It turns out that when you're looking for solutions, you can disregard everything in the middle for a polynomial. None of it matters. All that matters is the thing on that end and the thing on that end. And that's it. And that tells us solutions pretty quickly. Let's see it in action. Ben, how was that factor?
I don't know.
You don't know. But here's the cool thing. The fundamental theorem of algebra says that even things that don't look like they factor, everything factors. Everything. 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 It also says that whatever the degree of the polynomial is, that's how many factors it has. So 3 degree, 3 solutions, 3 factors. There's a number, Ben, that you can plug in here and get 0. Give me a guess.
A goobillion.
He's going to guess 1,000,000, okay? And he's wrong. Is it really tough to try to pick numbers anywhere between negative infinity and just like guess them that work? We're going to narrow your search from negative infinity to infinity. We're going to narrow that down. Here's how we do it. We look at our p's. What are factors of 6? 1, 2, 3, and 6. What are factors of 1? 1. Turns out, Ben, that when you want to think about the numbers to plug in to make 0, you should only think about these numbers. Your p's divided by your q's. 1 divided by 1 is 1. 2 divided by 1 is 2. 3 divided by 1 is 3. And 6 divided by 1 is 6. See, we took an infinite set of numbers and we said we're going to cut it down to just 8. That's pretty impressive. So now you choose one from here.
2.
He wants to try 2. You guys are okay for trying 2? Let's try 2. What's 2 cubed? 8. Minus 14 minus 6. Does that make 0? No, 2 doesn't work. But thanks for trying. -2. Let's see. Negative 2 cubed is negative 8. Is it going to be minus 14 or plus 14? Plus 14. Minus 6. Does that make 0? It does. Negative 2 works. We found one. We found one. We made a good educated guess. Among these 8, we found one. So it so works that if negative 2 is a solution, then what is the binomial? What is the binomial that divides into it evenly? X what? Plus 2. That's what divides evenly into it. That's one of the factors. If negative 2 is a solution, that's one of the factors. So in order to find the others, I just take the negative 2 and I divide it in. I have a 1, I have a 0, a negative 7, and a negative 6. What do? Drop the 1, multiply. Add. Multiply. Add. Multiply. Add. And if you don't get 0, you did something wrong. So this thing does factor because everything factors. It factors to x plus 2 times x squared minus 2x minus 3. And does x squared minus 2x minus 3 factor? What does it factor to, Connor?
X minus 3.
So that means we have solutions of negative 2, negative 1, and positive 3, don't we? We found the solutions. We used the rational roots theorem. And not only did we use the rational roots theorem, but our solutions, are they all rational? So they should all be sitting here. Are the numbers negative 2, negative 1, positive 3 sitting here? Yes, they are. Negative 1, negative 2, positive 3, they're all sitting right there. They're part of our solution set. I did that one for you. You help me with this one. What's the degree? What are my P's? What are my Q's? P's are 1, 2, and 4. Q's are 1. Choices are plus or minus 1, plus or minus 2, and plus or minus 4. Right now, between you and your partner, try to find one that works.
I know. Bless me. Morning was.
Oh, sorry. I thought. Sorry. I thought.
What'd you get? Who found one?
1.
He found 1. X equals 1. Way to go. That's all we need. That means that x minus 1 is a factor. Man, turns out that x cubed plus 3x squared minus 4, I didn't know it factors, but it does. It factors x minus 1 times x squared plus 4x plus 4. And then that factors to x plus 2 times x plus 2. So we have solutions of negative 2 and negative 2 with that. Hey, sketch a graph. See if you remember what we did on Friday. Fortnite!
Yeah.
How long would it take me to play Fortnite to beat you?
A long time.
Wow, well, you're that good, huh?
Connor's pretty good at Fortnite.
Do you play it on the phone? Do you play it on the computer? Where do you play it? A game console? How do you play it?
Xbox.
Xbox.
Yeah.
Sounds serious. Believe it or not, I don't own an Xbox.
What do you own? Do you own any?
Chainsaw? I got 5 of them.
Really?
Yeah, I'm running it this week. Going to Blotty's house. He's got a tree down. I'm going to cut it up.
Why do you need 5?
Huh?
Why do you need 5 chainsaws?
Why not? They're cool.
I know, but like,
People give me their chainsaws when they don't work anymore because they don't know how to fix them because people don't know how to do anything anymore in society. So I fix them, make them run.
and you keep that.
Well, yeah. Why do I throw it to the dump?
Yeah.
Here, I'll sell it. I'm going to give it to my son someday. Sometimes you need a bigger chainsaw. Sometimes you need a smaller one. You know what I mean?
Can I buy one? I'd like to buy
Yeah. Yeah, you can buy a chainsaw from me.
How much?
Well, I'll show you the model. But I'm thinking about $100.
They're that cheap.
Sure. Yeah, I mean, I got another one I'd sell you for $5, but I ain't gonna sell you
$5?
$500. I ain't gonna sell you my $500 chainsaw. It cost me about $800 to try to replace it. I mean, it's a really nice piece of machinery. So, all right, here we go. Remember this one I told you at the very beginning. It's the last one we do today. Okay. You guys admitted right away you got no clue, right? Hannah said I have no clue. Hannah has no clue. She got no clue how to factor this guy. But does it factor, Alex?
Yes.
Absolutely. Why? Because everything factors. There's nothing that doesn't factor. The degree is 3. There's 3 solutions. Uh-oh, look at our P's and our Q's. What are our P's this time? 1 and 3. What are our Q's? 1 and 2. So notice for your choices, you have to take each one of your P's and divide it by each one of your Q's. 1 divided by 1 is 1. And then 3 divided by 1 is 3. Then I got to move on to the 2. 1 divided by 2 is 1/2. And 3 divided by 2 is 3/2. Now this is where it's going to require some smarts on you guys. Okay, we got to grow as mathematicians on a daily basis. Here's something where you're going to grow. There are certain numbers there that are going to be very bad to plug in and try, and there are going to be numbers that are very good options to plug in and try. Have a conversation with Pierre next to you in 15 seconds. What are bad choices? What are good choices out of those 8? Go talk.
Fractions, no good. Bad fractions. We hate fractions.
Well, yeah, me too.
5, 4, 3, 2, 1. Somebody give me an option with something other than the word fractions. Why? Why?
Wait, why -1?
Yeah.
Does it work? What? I thought you were asking us to find one that works.
-1 does work.
Yeah. What? It's not a fraction, so it's a whole number.
Would positive 1 be a good choice?
No, because there's no negatives in there, so it can't be 0. Right? Or,
So if I'm plugging in those numbers, what are the only kind of numbers I should try?
whole numbers.
Negative.
Negative numbers.
Negative numbers. Does everybody see when you look at this that there is no way that you're going to plug in a positive and get a positive to work? You should only plug in negatives. So all of a sudden we've taken our 8 choices and we cut them down to 4. And we're going to start with the easiest one. We're going to start with -1. -1 cubed is -1 times 2 is -2. Is it going to be a +9 or -9? +9. Is it going to be a +10 or -10? And then it's a +3. Notice we got +12, we got -12. That makes 0. Remember, you don't get a calculator on this test. Okay? So you got to have some insight. You got to be able to think about it. You got to be able to move. You got to be able to be quick. -2 works, or -1 works. So x equals -1. That's a solution. That means that x plus 1 is a factor. I want to find the other factors because, like Alex said, everything factors. I drop the 2, and I multiply, I get -2. I add, and I get 7. Multiply, I get -7. Add, I get 3. Multiply, I get -3. Add, and I get 0. So I get x plus 1 times 2x squared plus 7x plus 3. And that factors to 2x plus 1 times x plus 3. I have solutions of -1, -3, and -1/2. and those are all listed right there, and they are all negative, like we made in our prediction. The analysis of our polynomial is complete. We have factored it, even though it seemed like it was impossible to factor. I thought that was cool. When I was in high school and I saw the rational roots theorem for the first time, I said to myself, I will be a math major. I thought that that was just something that, like, wow. I never saw the possibilities. But part of what's beautiful to me about this is this piece. What about all the other cubics? You guys know the quadratic formula, right? You could solve any quadratic by doing that, can't you? Do you know there's a formula for the cubic? There's a formula for the cubic, too. You can solve any of the cubics. It's a page and a half long. There's a formula for the quartic. It's 4.5 pages long. And it's been proven by mathematicians that it's not possible to come up with a formula for the quintic or anything above 5.
Why?
That's a hard question. I can't give you an answer. There are very intelligent minds that came up with that. But the solutions and the intrigue of mathematics, when there's solutions, where there's not, something pretty cool. It's my favorite unit. You guys saw some of this last year, didn't you?
Yeah.
Your biggest fault will be, oh, I learned it last year, so it's all going to be the same. Absolutely not. That is basically stuff that you learned last year. The whole rest of the new unit you haven't heard before. And so it's kind of like last year's unit on steroids. Not telling you to use steroids. Unless you got a sick goat or something. Give it some steroids. Feel better. Okay. All right, take out your homework.